Good morning, dear students. I am Mukesh Mishra, your chemistry faculty at Aakash, and today I am going to discuss the AIATS Plus Phase 2 Test 5th, which was conducted on 16th of Feb 2025. So I am going to take the chemistry questions. Basically, I will be taking the questions from GOC part, hydrocarbons, and haloalkanes and haloarenes. Okay. So let's begin the question, but before that, you should be ready with your pen pencil so that you can note down each and every concept which I am going to discuss here. Okay. So now the first question is, correct order of boiling point of the given molecule is. Okay. So this is the question and we have been given, we have to find the boiling point order and we have been given various alkyl halide. Now one thing we have to note, good morning Rajiv, that these haloalkanes, they have two parts, R and X. Okay, but R is same for all. You can see we have this CH3 whole thrice C. It is only differing in the case of chlorine, bromine, iodine. So only halogens is differing here. Okay, so now we have to, what we have to do here, we have to consider the fact that we have to check the order with regard to this. But before going to the answer, let us discuss first the physical properties of haloalkanes. This is the most important topic to solve this question. Physical properties of haloalkanes. Yes, Rajiv is saying, sir, mass is deciding factor. Good morning, Tanmay. Good morning, Sumit. Okay, so let's have a look here. Why mass is deciding factor? We will discuss all these things. But first, let us talk about the physical properties of haloalkanes, and I am going to discuss the melting point and boiling point first. So, okay. Now, one thing you have to understand that generally you will find that in haloalkanes, see, suppose the simplest haloalkane which we have is CH3X, then CH3, CH2X, then CH3, CH2, CH2X. So these are different types of haloalkanes. So I am taking X, first of all we will discuss the alkyl part and then we will move for the halogen part. Okay. Now you can see here that as the number of carbon is increasing, okay, so with the increase in number of carbon, the mass increases, and as the mass increases, what is going to happen? The molecule will tend to, it will increase, it will have more force, attractive forces, more, in terms of physics, you might have learned gravitational forces. Higher the mass, higher is the gravitational forces. But here in chemistry, we take it as a van der Waals forces. Okay. ठीक है, तो केमिस्ट्री में हम ग्रेविटेशनल फोर्स नहीं कहते, हम इसको वैन डर वाल फोर्स कहते हैं. ओके, तो जैसे जैसे मास इंक्रीज होगा वैसे वैसे वैन डर वाल फोर्स भी इंक्रीज होंगी. ठीक है, तो जैसे नंबर ऑफ कार्बन इंक्रीज कर रहा है वैसे वैसे वैन डर वाल फोर्स इंक्रीजेज with increase in number of carbon. Generally we take a number of carbon, because with the increase in number of carbon definitely mass will increase. So boiling point increases और इसी वजह से ऑर्डर क्या हो जाएगा, ये हो जाएगा. ओके, गुड मॉर्निंग अजय. सो यू कैन सी हियर दैट बॉइलिंग पॉइंट विल इंक्रीज विद द इंक्रीज इन नंबर ऑफ कार्बन. नेक्स्ट, इसके बाद एक और इंपॉर्टेंट चीज है कि अगर मान लो हमारे पास ये है, नेक्स्ट डिस्कस करते हैं कि अगर नंबर ऑफ कार्बन सेम हो जाए उस वक्त क्या होगा. वी हैव सेम नंबर ऑफ कार्बन, ओके. If this is the case, you can see here that there have, same number of carbons are present. All have 4. Their mass is also same. Okay. So we have to decide here on the basis of, surface area again. Okay. Now try to understand one very important thing. If the surface area is more, Kumaran says boiling point increases with increase in total mass of a straight chain. Here. Yes, sir. But Kumaran, you can see here, mass will be same. If suppose we take instead of X, I take chlorine. So they are all isomeric haloalkanes and their mass is same. So the problem of isomer is that, they have same masses. So on the basis of mass, you won't be able to decide. Now, what we have to think here, that if the molecule is straight chain, if it is linear, then it will have maximum surface area. And in maths, in physics also, you must have learnt that for a given amount of volume, for a given particular volume, which type of shape has minimum surface area, then you all have learned that a sphere has minimum surface area. Okay, so spherical things have minimum surface area. So you can see if the molecule is linear, then it is not spherical. Yes. So it will have more area of contact. Okay. Now, if the molecule, if the branches are increasing, the molecule is becoming spherical. And if it is becoming more spherical, then the exposed surface area will start on decreasing. And due to this, van der Waals force of attraction will decrease. Is this clear to all of you? So, if I take this as A, this as B, this as C, so you can note down that among the isomeric haloalkanes, with the increase in surface area, van der Waals force of attraction decreases and this leads to decrease in boiling point. Okay? So, this will have maximum surface area. So, A will be having the maximum boiling point. Then followed by B and then again followed by C. You can see here it is most spherical. It is having the maximum number of branches. So this will be the boiling point order. Good morning, Ishani. Now let's move on to the next concept, that what happens when the halogen changes and the alkyl part remains same. चलो, suppose हम लोग इसको लेते हैं CH3F CH3Cl सपोज ये सिचुएशन है हमारे पास. यस, अब इसमें किसका बॉइलिंग पॉइंट ज़्यादा होगा, ये हमें अगर सोचना है तो नाउ वी हैव टू सी द मास ऑफ दिस. You can see as we are moving down the group, the mass is increasing, and as the mass increases, we can see that van der Waals force of attraction also increases. Due to this, what happens that if it is A, it is B, and it is C. So you can note it down that on the increasing the mass, the boiling point increases. So C will have the maximum, then followed by B, then followed by A. Okay. So this is how we are going to solve our question. Now let's come back to the question. Question can be solved by this data only. Here you can see correct order of boiling point of the given molecule is. Now we have learned that R is constant here and there is change in halogen only, Cl, Bri. And we have just learned that with the increase in mass, as we move down the group, what is going to happen here? The mass will increase and so the boiling point will also increase. So iodide will have the maximum boiling point, followed by Br, then followed by Cl. So fourth will be the correct answer. Anyone having any doubt can ask. Okay. Now one more very important aspect is there that we consider for in the physical properties of haloalkane is solubility in water. So you must have learned that Rx is a polar bond. Okay, it has polar bond. X is having more electronegativity, so it attracts the shared pair of electron towards itself, due to which polarity develops. But this polarity, okay, is not sufficient to disrupt the hydrogen bonding of the water molecule, because water is also polar, and along with polarity it has hydrogen bond, and we have learned that among the intermolecular forces hydrogen bonding is very strong. So therefore, as haloalkanes cannot provide a stronger bonding than hydrogen bond which is already present in water. Due to this, what happens that these haloalkanes, even though they are polar in nature, they are insoluble, they are not soluble in water. Okay, and with the increase in number of carbon, non-polarity will increase, and as the non-polarity will increase, again they will become less soluble. Yes, Hilal, more mass, more boiling point. Okay, now तो ये सारी चीजें हमें इनके बारे में डिस्कस करनी है. चलिए अब हम लोग आगे डिस्कस करते हैं. नेक्स्ट, ये नोट कर लो सभी. Now, next is question 57. Ozonolysis of compound A result in the formation of propanone as one of the product. As one of the product, compound A is. Now, अगर आप लोगों ने मेरे प्रीवियस लेक्चर को देखा होगा तो वहां पर मैंने पूरी तरह से डिस्कस किया है. क्या चीज? ओजोनोलाइसिस का. इसमें दो पार्ट होते हैं, रिडक्टिव ओजोनोलिसिस एंड ऑक्सीडेटिव ओजोनोलिसिस. आई हैव डिस्कस बोथ ऑफ देम इन माय प्रीवियस लेक्चर. यू कैन गो बैक, यू विल फाइंड इन द live section that there is ozonolysis heading there. You can watch this video, this concept in detail there. But again, I will discuss very shortly here also, don't worry. That ozonolysis of compound A result in the formation of propanone. So propanone is CH3C. This is propanone, okay? And we have learnt that during ozonolysis, what we have to do, we just have to break the double bond, and instead of double bond, we have to provide double bond O to both the region. Now, what is going to happen here? Suppose, if this compound undergoes ozonolysis, this trick I have discussed in my previous lecture. Okay. Now, what will happen? We will get two products. Here we have one carbon. Okay, carbon with, so this will give HCHO plus okay, Rahul. Now Rahul is saying second option. Hilal is saying, Rahul is saying fourth and Hilal is saying second option. Now let's have a look that which one will be the correct. Now, is it propanone? None of them is propanone. So we have to find out propanone here. So if this product undergoes, here we have carbon here, so it will again form CHO, and you can see here this one is having the carbon here. So next, CHO will be here followed by this. So it is also not going to produce propanone because it is both are aldehydic group. Okay, so second is not the correct answer. So Tanmay and Hema Malini Shetty are saying, sir, option 4 should be correct. Let's check option 3 first. So here what we are going to get, again we have 1C, 1C. That's why you should watch my previous lecture where I have discussed ozonolysis in detail. CHO. So third is also not going to be the correct answer. But here, if this undergoes ozonolysis, then what we are going to get? Now, this is the propanone which we have to, find out. So, option 4th will be the correct answer. Anyone having any doubt can ask. Now, as we all know that this is only about the reductive ozonolysis. In your NCERT, they are talking about reductive ozonolysis, but you should also know that in oxidative ozonolysis, what is the difference? The difference is that instead of zinc water, we are going to use zinc and peroxide. And due to this peroxide, what happens is that the substance, if any aldehyde is being formed, this aldehyde will also get oxidized to carboxylic acid. Okay, is this clear? So this is so 4th will be the correct answer. Now let's move on to the next question. It is an AR question, so very interesting one. Given below are two statements. One is labeled as assertion A and other is labeled as reason R. Assertion A: when alkyl halide is reacted with AgCN, then alkyl isocyanide is formed. And reason, they are saying that, AgCN is a covalent compound and only the site of nitrogen is available for the reaction. Now to solve this, okay, you have to be aware of the nature of the carbon halogen bond. Okay, CX bond, why it is polar, what happens when, how it reacts, and CN, the reagent is acting as a nucleophile here. So you all should be aware of the mechanism of the nucleophilic reaction here. So we are going to discuss first the nature of RX bond. So if we talk about carbon halogen bond, this halogen has developed, it is more electronegative, so it will develop negative charge, then partial negative charge, because the electrons, this covalent bond electron will move towards halogen, and this carbon will develop a positive charge. Okay, now the X can be, a very interesting question arises from here. F all the molecules, they are polar in nature. Okay, so as they all are polar in nature, then definitely bond polarity will be there, and bond polarity is measured in sense of dipole moment. Mu, and we all know that dipole moment mu is equal to Q into D. Q means charge that has been developed here, and D means the distance between the two. Okay, now one very interesting thing you have to understand: higher the value of this, higher will be the polarity. Okay, so now you have to consider the fact that more is the electronegativity, more will be the charge developed. There is an exception which arises here, so that's why I am going to discuss this. Tanmay is saying 2, 1, 3, 4. Okay, now you have to find out that which of the bond out of the CS3F, CS3Cl, CS3Br, CS3I, which of them is going to have the maximum bond polarity or maximum dipole moment. Most of the time, students only consider one factor, that they think that, okay, fluorine is most electronegative, so it will have the maximum polarity, and that's why CS3F will be the maximum polar bond. But that is not the case here. Actually, what happens, this distance is also a very important factor here. Okay, and due to this, what happens, that see, fluorine is a small molecule, Cl. As we move down the group, the size increases, the bond increases, the D increases, and because of this, increase in, because of this increase in the size, actually what happens, the product of Q into D for CS3Cl becomes higher than CS3F. Okay, so that's why the order for bond polarity, okay, will be this very interesting case, and most of the time a student commit mistake here. CS3Cl will be most polar, followed by CS3F, then followed by CS3Br, then followed by CS3I. Okay, is this clear? Yes, Ajay Kumar Verma, you are absolutely correct that CH3Cl is maximum polarity. Now the actual value of data is given in your NCERT in Haloalkanes Haloarenes chapter. You can go back there and check it out. So this is the case here. But let's come back to the question. Our question is asking that, okay, when alkyl halide is reacted with AgCN, alkyl isocyanide is formed. Now this discussion was necessary to explain one very important fact, that if a nucleophile attacks on this bond, then you all know that nucleophile are nucleus loving, and so therefore they will attack those centers which have positive charge on them. So therefore what happens, that any nucleophile will attack the carbon and nucleophilic substitution will take place. So I have already discussed in my first lecture about the SN1 and SN2 mechanism. You can go back and check there. But what we are going to discuss here is about AgCN. Suppose we have Rx. Now, a concept of ambident nucleophile arises. Okay. So generally, if you talk about ambident nucleophile, then they have two nucleophilic centers, but only one can attack at a time. Okay. So one of the example is Cn minus. Negative charge is on the carbon and nitrogen has lone pair. Okay. Now, out of, you can see here that nucleophile should be electron rich. It should either be negatively charged or it should have lone pair of electrons which can participate in bond formation. Therefore, what happens here, that either of this negative charge or the lone pair of nitrogen can act as nucleophile here. Okay. Now, what we have to think, that if carbon is going to attack this R, okay, in that case, what will be the product? We will get carbon-carbon bond. Okay, R will form bond with C and we will get nitrile. Okay, or we will get cyanide, sorry. And if this lone pair of nitrogen, if this attacks the R, at that time we are going to get isocyanide. Okay, so two situation arises. Rx KCN के साथ रिएक्ट करेगा और AgCN के साथ रिएक्ट करेगा. Okay, if Rx reacts with KCN, then we know that KCN is a ionic compound, and due to this ionic nature, it will dissociate to produce K plus and Cn minus. Now, out of these two, negative will have more impact as a nucleophile. So therefore, what will happen in this case, this negative charge on the carbon will attack this and we are going to get RCN, which is cyanide. Okay, but in this case, what is going to happen here in case of AgCN? This bond is covalent. This is covalent in nature, and because of this covalent, this negative charge, will not be available for, it will be used in covalent bond, so it will not be free, and therefore lone pair of nitrogen will attack this carbon, and what is we are going to get? We are going to get RNC. Okay, and in return we get isocyanide. Is this clear to all of you? So this is the fact here. This is a very important discussion which you have to consider. Now let's come back to our question. When alkyl halide is reacted with AgCN, then alkyl isocyanide is formed. And this, we have discussed right now, that when Rx reacts with AgCN, we get isocyanide. Okay, so this statement is absolutely correct. AgCN is a covalent compound and only the site of nitrogen is available for the reaction. This we have also discussed, and this reason is also explaining the assertion. So definitely, what should be our answer? Both assertion and reason are correct statement, and reason is the correct explanation for the for the assertion. So therefore, option 1 will be correct here. Anyone having any doubt? You are free to ask. Is this clear? Can any one of you name another ambident nucleophile? Yes. One more ambident nucleophile. That is NO2 minus. Okay. So if NO2 minus is there, okay. Similarly, what is going to happen here if this compound is allowed to react with, if this Rx, is allowed to react with AgNO2. Now again, in NO2 structure, yes, not NO2, NO2 minus. Okay. So now again the bond is covalent. This nitrogen lone pair will attack here, and we are going to get RN2. So nitro compounds will be obtained here. Okay. Now if we allow it to react with KNO2, again NO2 minus. So negative charge that is present on the oxygen will form bond with carbon, and in return what we are going to get? RO, iso nitrogen. Is this clear to all of you? Okay. So this was the discussion about ambident nucleophile. Yes, crystal clear. Okay. Now let's move on to the next question. So here you can see the next question is all about Carius method. Again, Carius method has also been explained completely in my previous lecture. If you want a detailed discussion, you can go back to the live series, and there you're free to watch that. Now 0.355 gram of an organic compound gives 0.435 gram of an AgCl. Now again, how you have to imagine this, I will discuss. See, we have been given an organic compound. Okay. This is an organic compound, let's assume, and its mass is 0.355 gram. Okay. And from this 355 gram in the Carius tube, what we are going to get? We are going to precipitate 0.1435 gram of AgCl. So AgCl is 0.1435 gram. Okay. Now what we have to think here, that all the chlorine that was present here has now moved to this Cl. Okay. Now by stoichiometry, if I find out the amount of Cl that is present in AgCl, what I am going to get? The actual content, actual amount of Cl that was present in this compound. Okay. As we have transferred all this here. So if you talk about the mass of silver is, yes Rahul, Carius method. Mass of silver is 108 gram and mass of chlorine is 35.5 gram. So if you add these two, you are going to get 143.5. So by stoichiometry, we can say that 143.5 gram AgCl has Cl. How much? 0.14. Sorry. Has how much Cl? 143 according to stoichiometry, 35.5 gram. Okay. Now 1 gram AgCl and 0.1435 gram. So 0.1435 gram AgCl has Cl, that is equal to 35.5 divided by 143.5 multiplied by 0.1435. Okay. Now this is the actual amount of silver that was present in our organic compound. So we have to find out the percentage of Cl. So percentage of Cl will be 35 percentage of chlorine will be 35.5 into 0.1435 into 143.5 into multiply the amount of organic compound, because we have to divide. In order to find out percentage, we take the amount that is we have obtained divided by total mass of the organic compound. So total mass of organic compound is 0.355 multiplied by 100. And on solving this, what is the answer? Can anyone tell in the comment box? The answer obtained will be, the data is such that you don't have to worry about calculator or calculation. The answer will be 10%. Okay, on solving this you get 10% as the answer. Now let's move on to the next question. This is what question number 56. In the reaction, benzene reacts with 3Cl2 in presence of UV and 500 Kelvin. Okay. Now, so we have to tell the product that we obtained here. So this is this you have to remember, memorize all these things. So this is there in hydrocarbon chapter, and in this case your product will be option 1, benzene hexachloride. Okay, so first will be the correct answer here. Anyone having any doubt? Exactly, Hema Malini. That first is going to be the correct answer. Now, one more very important question is there, that what happens that if we allow it to react with Cl2 in presence of AlCl3 in dark, at that time we are going to get option number 3. Okay, and in what situation we get this Cl? So this Cl is obtained when we allow Friedel-Crafts halogenation. Okay, sorry, not electrophilic substitution for halogenation. So this is obtained when benzene reacts with Cl2 in presence of AlCl3. At that time we get Cl as the major product. Is this clear? Yes. So now let's move on to the next question. Now this is a very interesting one. The compound which does not show the hyperconjugation is. So discussion of hyperconjugation is very important, that I am going to take now. So you all should be ready with your pen, pencil and note down some important extra point which I am going to discuss. Now try to find out one thing, that hyperconjugation. Okay. First of all, you have to know that this is actually a permanent effect. Okay. And hyperconjugation has an stabilizing effect. And on what type of molecules it is applicable? Hyperconjugation is applicable on carbocations, free radicals, and then alkenes. एल्काइंस पर भी इनका इफेक्ट होता है, बट उतना ज़्यादा हम नहीं करते. राहुल इज सेइंग फोर्थ ऑप्शन इज करेक्ट. सो तो हम पहले ही चेक कर लेते हैं कि भाई इनमें से क्या है. यहाँ पे डबल बॉन्ड प्रेजेंट है, ये एल्कीन है यहाँ पर, और फोर्थ कार्बोकटायन है. यस, दमाती कृष्णा इज सेइंग सर ऑप्शन 3 is correct. Madhushri, sir, option number 3. Now Rahul, you have to watch the complete discussion here, that what is the concept which we apply for hyperconjugation. Now hyperconjugation, let me tell you one thing, that it is we call it as a sigma bond which is there. Suppose I take a simple example of this, CH3CH2. I am taking example of this for Rahul. You can see here that it has 3 hydrogen. CH2 plus is there. Okay. Now you will find that this carbon is sp2 hybridized and it has one empty p orbital. Okay. One empty p orbital is present, which is unhybridized. Okay. So actually what happens here, that this sigma bond, it will donate its electron here and in return, see these two electrons will move here. So H plus charge will develop here. Okay, so this thing is correct. Okay, so this is how what happens here, that this sigma bond has become pi bond. So sigma to pi bond formation takes place. But let me tell you one thing, that this hydrogen is still there in the vicinity. It's not that it will move on and move away from this system. So it will always remain attached to this CS3 only. So that's why actually what happens is that this sigma to pi transfer actually increases the stability for carbocations. Same happens in case of carboanions also. Okay, so therefore this is having an stabilizing effect. Now, how we can find out that, if I take a various example here, that CS3 plus, suppose we have this CS3 plus carbocation is there, CH3, CH2 plus is there, then CS3, CS3, H plus is there, okay, and then we have this thing is also there. So the stability of these carbocations can be explained with the help of hyperconjugation. Okay, with plus I also some people try to explain this, but most accurate form is that you have to apply the concept of hyperconjugation. You can see here that CS3 plus, no other carbon is there, no other carbon is there in vicinity. So that's why what is happening here, that this CS3 plus is 0 hyperconjugates are there. Okay, but with this carbocation, what is going to happen? It has 3 CH bonds. So 3 hyperconjugates are there. For this, again, 3 from this side, 3 from this side. More alpha hydrogen, more hyperconjugation, more stability. Very good. So you can see 6 hyperconjugation. And this thing, it has 9 hyperconjugation. So higher the number of hyperconjugation, hydrogen available for hyperconjugation, higher will be the stability of the compound. Okay, is this clear to all of you? Due to this, actually what happens, that this tert-butyl carbocation is most stable. So you can note down higher the number of hyperconjugation, higher will be stability. Okay, so this is the case which is going to happen. So this one is most stable, followed by this, and this methyl carbocation will be very less stable because it does not have hyperconjugation structure. Now what happens in case of alkene? That also I will discuss. Suppose we have CH3, CH double bond CH2. Okay. अब इस केस में क्या होता है, इसको भी आप लोग नोट कर लें. You can see here. This again, it has one empty orbital. This because it is sp2 hybridized, so one unhybridized orbital is there. So now what will happen? This hydrogen will move. This bond of hydrogen will move here, and this will move here again, and due to this, what is going to happen? C double bond C, H plus remains in vicinity. Again you can see this hyperconjugation, again it is a stabilizing orbital. हाँ यस राहुल, यू फॉरगॉट अबाउट द एमटीपी ऑर्बिटल। इस चीज़ का ध्यान रखना है आपको जब भी आप इस तरह के क्वेश्चन को सॉल्व करें तो। अच्छा, एक और इंपॉर्टेंट पॉइंट मैं बता दूं, कार्बो अनायन के केस में जनरली हाइपर कंजुगेशन हैज़ नो इफेक्ट। एक क्वेश्चन हमारे AITS प्लस में ही पहले आया था और काफ़ी बच्चों ने उसको गलत किया था। कार्बो अनायंस के केस में हमें हाइपर कंजुगेशन का इम्पैक्ट अफेक्ट नहीं देखने को मिलता, बहुत रेयरली कहीं पर हमें वो चीज़ें हैं। जनरली कार्बो अनायंस पे जो आपके लेवल पर बातचीत की जाएगी हमेशा उसमें हाइपर कंजुगेशन का इम्पैक्ट नहीं मिलेगा देखने को, ठीक है। तो ये चीज़ आपको ध्यान रखना है। तो इस तरीके से अगर फिर सेम चीज़ आती है कि जिस एल्कीन में ज़्यादा नंबर ऑफ हाइपर कंजुगेट्स हैं, ज़्यादा नंबर हाइड्रोजन के अवेलेबल हैं फॉर हाइपर कंजुगेशन, तो उसकी वजह से क्या होता है कि स्टेबिलिटी एल्कीन की भी बढ़ती है। और कई बार जब आप देखेंगे कि प्रोडक्ट, बहुत जगह पर जब आप हायर स्टडीज़ में पढ़ेंगे तो वहाँ पता चलेगा कि जो प्रोडक्ट की स्टेबिलिटी है, स्टेबिलिटी ऑफ एल्कीन, दैट डिसाइड्स दैट व्हाट इज़ द प्रोडक्ट विच वी आर गोइंग टू गेट। सो वो उस केस में काम आएगा, ठीक है। चलिए, टिल देन अभी हम लोग इसको यहाँ पे डिस्कस करते हैं। अब इसके बाद एक और इंपॉर्टेंट पॉइंट है जो आपको समझना है। इन केस ऑफ फ्री रेडिकल, अगेन द कंसेप्ट इज सेम व्हाट वी हैव डिस्कस्ड फॉर कार्बोकटायंस। एग्जैक्टली। सो delocalization of these are sigma electron, sigma bond, and now this sigma bonds, they are getting delocalized to form pi bond. So it is also called sigma pi delocalization. Anything else which you want to know? चलिए, तो हम अपने क्वेश्चन पर आते हैं। अब बताओ इसमें से करेक्ट आंसर क्या होगा? What will be the correct answer here? चलिए बताइए। द कंपाउंड विच डज नॉट शो हाइपर कंजुगेशन। अब देखो यहां पे ये तो हमने शो देख ही लिया एग्जाम्पल में ही। ओके हिलाल, यू कैन सी वी हैव डिस्कस दिस राइट नाउ, और इसको भी हमने डिस्कस कर लिया दैट दीज टू आर गोइंग टू शो हाइपर कंजुगेशन। बच गए हमारे पास दो, बेंजीन एंड ये। अब आप सोचेंगे सर आपने कार्बोकटायन में तो बोला था, बट वही मैंने कहा था कि हमेशा हमें ध्यान रखना है कि कार्बोकटायन कैसा है। ओके, हेमा मालिनी सिंह सर ऑप्शन 3 इज करेक्ट। लेट्स हैव ए लुक। यहाँ से ये बॉन्ड यहाँ ट्रांसफ़र हो जाएगा और ये नेगेटिव चार्ज यहाँ पे मूव ऑन कर जाएगा, ठीक है। इसकी वजह से क्या होता है, दिस नेगेटिव डबल बॉन्ड CH H पॉजिटिव, और इस तरह का हाइपर कंजुगेशन हमें देखने को मिलेगा। ओके, सो वी कैन सी हियर दैट इट इज शोइंग हाइपर कंजुगेशन। Yes, NEETs is also saying sir option 3 is correct. But now let's have a look here about this. Okay, this carbon it is having the positive charge, and it is not sp3 hybridized. It is also having one empty p orbital. And what happens that due to this positive charge, this bond moves here. Okay, so exactly Hilal. So toluene shows hyperconjugation. और मैंने दिखा दिया अगेन रेजोनेंस स्ट्रक्चर आप इसके बना सकते हैं, बहुत आगे बनते जाएंगे। बट यहाँ पर ये जो चीज़ है, यू कैन सी हियर दैट हियर इट इज़ नॉट पॉसिबल, सो दैट्स वाई ऑप्शन 3 विल बी करेक्ट आंसर। सम टाइम स्टूडेंट आस्क दैट सर ऐसा क्यों नहीं है कि अगर मान लो CH3 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 CH2 प्लस है। स्टेबिलिटी ऑफ कार्बोकटायन कई बार आपको ये डिसाइड करने में हेल्प करती है कि मार्कोनिकोफ एडिशन में आपने देखा होगा दैट वाई मेजर प्रोडक्ट इज बीइंग फॉर्म्ड, तो वहाँ पे स्टेबिलिटी ऑफ कार्बोकटायन का बहुत इंपॉर्टेंट रोल है। अब जब इस तरह का कार्बोकटायन बनता है तो यहाँ पर आप मिथाइल शिफ्ट की बात करते हैं। ओके, तो कई बार बच्चे पूछते हैं कि सर ये ऐसा क्यों नहीं हो सकता कि कार्बन कार्बन से ही शिफ्ट हो जाए, ये सिग्मा पाई ट्रांसफर ही तो करना है। sigma bond is also there. Okay. So for that you have to understand that symmetry in energy is also a very important concept. So carbon hydrogen की जो sigma bond है, that has number of alpha hydrogen. Number of alpha hydrogen तो इसमें यहाँ पे कितने हैं? 0 है, because this carbon is alpha carbon and it is not showing any hydrogen. It does not have any hydrogen. So number of hyperconjugates are 0 here. But question ये है कि कार्बन कार्बन से क्यों नहीं हुआ hyperconjugation? ये चीज़ इंपॉर्टेंट है, ये आपको समझना है कि एनर्जी में सिमेट्रिकल नहीं होता है. हाइब्रिडाइजेशन का कॉन्सेप्ट है या फिर रेजोनेंस का कॉन्सेप्ट है, तो ऑलमोस्ट नियरली सिमेट्रिकल, नियरली इक्विवेलेंट एनर्जी के होते हैं वो सभी, तभी एनर्जी का यहाँ पे बॉन्ड फॉर्मेशन पॉसिबल है. तो ये सिर्फ CH बॉन्ड के केस में देखा जाता है. सो दैट्स वाई वी गो फॉर नंबर ऑफ हाइड्रोजन. सो इज दिस क्लियर? इट हैज़ 0 हाइपर कंजुगेशन एंड देयरफॉर इट इज़ नॉट स्टेबल. और जब भी आपने कभी इस चीज़ को पढ़ा होगा कि ये कभी भी एडिशन प्रोडक्ट में बनता है किसी भी एल्कीन के, उस सिचुएशन में या कहीं पर भी, तो हाइड्राइड शिफ्ट जरूर होती है. हाइड्राइड नहीं, मिथाइल शिफ्ट जरूर होगी. इज दिस क्लियर टू ऑल ऑफ यू? सो दैट मोर स्टेबल कार्बोकैटायन इज बीइंग फॉर्म. यस. नाउ let's move on to the next question. That aniline is separated by which technique from aniline water mixture? Yes, बताइए आंसर. तो यहाँ पर अगर आप ध्यान देंगे तो आंसर हो जाएगा स्टीम डिस्टिलेशन. एंड यू नो आई एम गोइंग टू डिस्कस अबाउट डिस्टिलेशन. Now, distillation is a technique where we have, we are going to separate compounds. Okay, दमाते कृष्णा 2. आंसर सबने बता दिया, आंसर तो मैंने मार्क कर दिया है. ओके, अभी और क्वेश्चन पूछूंगा, उसके एग्जांपल बताना. ठीक, यहाँ ध्यान दो डिस्कशन पे. डिस्टिलेशन में फर्स्ट ऑफ ऑल वी आर गोइंग टू सेपरेट 2 डिफरेंट कंपाउंड्स. और जब भी हम कभी इस तरह की डिस्कशन करते हैं, इस तरह का हम टेक्निक यूज करते हैं, तो देयर इज अ प्रिंसिपल बिहाइंड दिस. Now the principle for using distillation is that there is difference in the boiling point of the substance, generally organic compounds, that we are going to separate out. Okay. Now what happens? Simple अगर हम बात करें simple distillation की, rough diagram I am going to draw. We are going to take this mixture A plus B. Okay. A has higher boiling point than B. Okay. Now, if you heat this, what will happen? B will forms vapors, and these vapors will be collected and cooled because B has lower boiling point. So it will, vaporize faster than A. So due to which, what will happen? B will be collected here, cool down, and will be separated. So this is, basic simple technique we are going to use. But there are other different methods also. Different types of distillations are also there. One of them is this distillation. One of them is fractional distillation. Okay. In fractional distillation, what is going to happen? We use a fractionating column. Just like orthonitrophenol versus paranitrophenol, we use steam distillation. Exactly, steam distillation I will discuss, and yes, this is also an example of steam distillation, that how orthonitrophenol and paranitrophenol, they can be separated from with the help of steam distillation. Don't worry about that. In fractional distillation, we are going to use fractionating column. Now, fractionating column is a type of column where different types of micro beads are there. Now these spherical beads, what they do, they actually increase the surface area. Fractionating column, हम use करते हैं fractionating column में different types of beads are there. Now try to understand this, that what these beads actually do. Suppose A plus B is there. Now when the vapors will come and enter into this fractionating column, these beads will increase the surface area for temperature exchange. Okay. So the molecule, if A plus B are there and we are heating them and their vapors are very, are both the vapors of A and B are being formed here, then what is going to happen? That this A, which is having the higher boiling point, what will happen? It will cool down faster. Its temperature will come below, and what will happen? Its temperature will cool down below its boiling point and it will come down back. And the substance which is having the lower boiling point will be able to pass through this fractionating column. Okay, so again, above this, it will be obtained in the liquid, in the vapor form, B will be obtained and it will be cooled down. So fractional distillation of petroleum, you all have learnt that petroleum is allowed to undergo fractionating through fractionating column, and we obtain different types of products, petrol, diesel, kerosene, paraffin wax, all the substances are used here. So one very important thing here you have to understand, that these two are used. This distillation is used when temperature difference is above somewhere about 25 degrees Celsius. The boiling point difference is there. But if this difference is below 25 degrees Celsius, then we have to go for fractional distillation. So fractional distillation is used when the substance which are being separated have very little difference in their boiling point. Okay, तब हम fractionating column को use करेंगे. Now one more very important distillation is there, distillation under reduced pressure. Okay, अब इसका एग्जाम्पल बताइए. सबके एग्जाम्पल इंपॉर्टेंट हैं. Distillation under reduced pressure, when it is used, and an example of it. जितने भी आपके 4 टाइप्स के डिस्टिलेशंस हैं, सबका आपको एग्जाम्पल याद रखना है. एंड मैच द कॉलम में भी आ सकता है, स्टेटमेंट फॉर्म में भी आता है, AR के फॉर्म में भी आ सकता है. तो बहुत अच्छे क्वेश्चंस डिस्टिलेशन से हमारे लिए नीट के पॉइंट ऑफ व्यू से बन जाते हैं. तो देखो, डिस्टिलेशन अंडर रिड्यूस्ड प्रेशर. नाउ यू ऑल हैव लर्नड that when we reduce the pressure, actually boiling point of any liquid decreases, or if any of a substance decreases. Now iska reason kya hai? Because boiling point is the temperature where what happens? Where glycerol. Boiling point is the temperature where the vapor pressure of liquid becomes equal to atmospheric pressure. And if you decrease the atmospheric pressure, less vapor pressure is required, so you have to heat a little bit lower. So that's why we use distillation under reduced pressure for those substances which have very high boiling point. But and they can also get decomposed at high temperature. So at that case, we are going to use the distillation under reduced pressure. And glycerol is, from in soap industry, it is distinguished, or it is separated from spent lye by distillation under reduced pressure. So this is the basic one. Now one more important was steam distillation. So it is used for those type of mixture in which one of the compound is steam volatile, but it can be steam volatile, but it is immiscible in water. So at that time we go for steam distillation. We actually supply vapors of water, and the steam volatile component will move out and it will be allowed to cool, and once it is get cooled, then we definitely get our product, because when it get cooled, the liquid becomes immiscible with water and separates out easily. So this is the basic feature for steam distillation. Okay, and this example is in NCERT. It has been given, the example for steam distillation is aniline water mixture. Okay. Yes, glycerol hilal is example for, glycerol has example for distillation under reduced pressure. And again, one of the student has discussed, had given example of orthonitrophenol, paranitrophenol. Yes, they also can be separated by the steam distillation. Okay, so these were the questions which were from these 3 parts. Now, other teachers, they will be joining very soon to discuss other topics of the same paper. So till then, stay tuned, stay connected Have a great day ahead.